Namaste all. I'm Mrs. Saraswati, working in DAV Boys Mogaper School. I would like to introduce ray diagrams and some numericals. That was what was required by you people. Many people had asked for that. So I thought I will go into teaching the ray diagrams and how to interpret it with the numericals that come. Okay. So to start with, let me screen share. So to start with reflection and refraction, we are going to first discuss reflection. The rules for drawing the ray diagrams are very important. They have to be very clearly taught to the students because they should know what two rays they need to use to draw the ray diagrams. So I think you're all familiar with the ray diagrams. I can just quickly browse through this. The first one being ray traveling parallel, passing through the focus, and the second one through the focus traveling parallel. The third rule is passing through C gets reflected along the same path because any ray passing through C will act as a normal. And the last rule here for concave mirror is a ray which makes an angle I with the point of incidence P makes equal angle with the reflected ray makes an equal angle with the normal. The normal here is going to be the principal axis. So why we insist on these ray diagram path of the rays is they may ask questions wherein they give only one part of the ray and ask the child to complete the ray diagram. So I think it is very important we insist and they are very clear about the rules. A ray parallel to the principal axis after reflection appear to diverge because convex mirror is a diverging mirror and appear to pass through the focus. So all the rays here are the virtual rays. So virtual rays we indicate using dotted lines. Then we have a ray which is directed towards the principal axis, which appears to pass through the principal focus. After reflection will travel parallel. Then a ray directed in the direction of center of curvature. When it is appearing to pass through the center of curvature will get reflected along the same path. Why? Because any ray passing through the center of curvature is going to act as a normal. For that matter, even the principal axis is going to act as a normal. And of course, the last rule is a ray which is incident at the point P of the convex mirror will make equal angles. That is, the reflected ray will make the same angles. If I is going to be 30, R will also be 30 degrees. And this is the fourth rule that we need to apply. Ray diagrams. First of all, it is at infinity. When an object is placed at infinity, the image is going to be formed at the focus, which is a real inverted and highly diminished image. I hope you are all familiar with the ray diagrams. I think the children should be taught how to draw ray diagrams, which is very important. We are going to use a minimum of 2 rays to draw the ray diagrams. So we should choose the correct rays, and the path of the rays after reflection should be known to draw the ray diagrams. You can teach the children to take measurements and draw the ray diagrams. The distance between P and F, if it is taken to be 2 centimeters, the distance between F and C should be taken as another 2 centimeters. By taking measurements, and if they position the object at the right position, say for example, this is B on C, at the correct position, and here we are going to choose 2 rays, a ray that is parallel to the principal axis, after reflection passes through the focus, and the other ray through the focus after reflection travels parallel to the principal axis. So you get a same size real inverted image. When the rays meet below the principal axis, they give you a real inverted image, and the rays meet above the principal axis, they give you a virtual erect image. So, this is the position between C and F. The object is positioned. What are the 2 rays we are going to take? The ray that is parallel to the principal axis passes through the focus, and the other ray through the center of curvature gets reflected along the same path. Yes? So they are after reflected rays meet at a point below the principal axis, and if you compare the size, it is going to be enlarged. Here again, if you ask them to take measurements and then position the object and draw the rays, automatically you will get it at the right position. This is at focus. Here again, two rays traveling parallel, passing through focus. The other ray through the center of curvature gets reflected along the center of curvature. And this is, of course, the last diagram positioned between P and F. The object is between P and F. So there are three rays shown here. A minimum of two rays is enough. A ray traveling parallel, passing through the focus. The other ray through the center of curvature, which meet. They appear to meet at a point behind the mirror. So you use virtual rays, and the virtual image is also shown using dotted lines. They insist on this even in the board exam. The rays should be marked with dotted lines, and even the image should be marked with dotted lines. Any doubts here? Then this is image formation by convex mirror. The object is at infinity. The rays appear to diverge from a point. So the image formed here will be a highly diminished image, which is virtual and erect. Where do we come across the situation? Where do we see this such a kind of image formation? This is at any position in front of the mirror. So here a ray traveling parallel will diverge and appear to come from a point called the focus. The other ray through the center of curvature. So here again, it should be a virtual image. They intersect here. You can see that it is above the principal axis. So it is a virtual erect image which is diminished. Where do we come across this situation? Any idea? Let it be an interactive session. Just tell me where you come across this situation. This kind of ray diagram, in day-to-day life, we see this. Where do we use this? Yes? What about the rear view mirror? The mirror that we use in our parking lot, the mirror that we use in our rear views, mirror in vehicles, all these are based on this. Any object that is coming behind, we view it as a diminished image. And you would have also seen on the rear view mirror, they would have printed the objects appear closer than the actual position. So you can see that the image distance is much less than the object distance here. So we can, as we teach the diagram, we can also give examples where that particular situation is used. So it will be useful for them to correlate and learn. So this is the image formation by a convex mirror, which I was talking to you about. So the object is here. It appears to be diminished, virtual, erect, and this is the center. These are the points: the focus, the center of curvature, and the principal focus is here. This is point P, which is the pole of the mirror. Now, what is very important before we teach the problems is making them understand the sign conventions for spherical mirrors. So if you take this is a concave mirror, this is a convex mirror. The principal axis of the mirror is taken as the x-axis of the Cartesian coordinate system. The principal axis of the mirror is taken as the axis of the Cartesian coordinate system. Can you see here? I think you know how you would have all taught how to draw a graph. We normally divide the graph sheet into 4 like this. The pole of the mirror is taken as the origin of the coordinate system. Okay. The object is always placed erect in front of the mirror, be it concave, be it convex. So object is always placed to the left of the mirror. Hence, the light from the object always falls on the mirror from the left-hand side. So this is going to be the direction of sunlight. The light is going to fall from the object on the mirror like this. Then, This is going to give you the object distance. The object distance here is measured against the direction of light. The object distance is measured parallel to the principal axis or always measured from the pole. So you keep the zero of the scale here and measure it in the opposite direction. So the direction of the sunlight is like this. The direction in which you measure the distance is going to be opposite to that. So anything that is measured to the left of the pole are taken as negative. So U is always negative. Okay. So if the image is going to be formed behind the mirror, then if it is going to be along the direction of light, then you take V to be positive. But U in both the cases are going to be always negative. So all distances measured to the right of the pole are taken as positive. All distances that are measured to the left of the pole are taken as negative. Am I clear? Then yes, height which is measured perpendicular to the principal axis are taken as positive. The heights measured perpendicular below the principal axis are taken as negative. So if the image is going to be a virtual erect image, it will H dash will also be positive. If the image is going to be a real, inverted image, then it will be taken as negative. H dash will be negative. So I want you people to participate and answer these questions. Case 1, what do you think it would be? I think it went off. 1 minute. 1, what do you take H as? Please answer, otherwise it is, if I'm alone going to talk, it will not be very interactive.
That is height, madam. First case, height. Second one, image. Below
image
the
height. Okay, good. How do you take it? What do you take 1 as? Positive or negative?
Positive.
Can you give the sign?
Positive. Positive.
2?
Negative.
Negative.
Negative. Okay. What is 3?
The parallel to the principal axis, madam.
Yeah, what is that? It is the distance between
image distance.
Image distance, because you cannot keep any object upside down. Object is always kept erect. What about 4? What about 4?
Change the diagram. 4.
What is 4? Distance between pole and the focus, what is it called?
Focal length.
Focal length. Is it positive or negative?
Negative.
In this case, negative, because it is on to the left hand side.
Left hand side.
Yeah. What about U here? Distance 5.
U.
Negative.
Negative.
U is also negative because it is on the left hand side. Is it clear?
Yes, ma'am.
So how you can teach them sign conventions by drawing it on the board. Okay. Now, can we just discuss this case? What about 1?
Object.
U negative, madam. Object is
height.
H.
Height.
Height of object.
Height.
Height of the object.
Height of the object is
Positive.
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 What about 2? Height of the image.
Height of the image.
The image also positive.
Positive. Very good. Because it is above the principal axis.
Axis.
What about 3? The distance between
radius of
3 is
curvature.
the
Positive.
Radius of curvature.
radius of curvature. Very good.
Radius
What
of
is it?
curvature.
Positive. Because it is along the direction of light. You keep the zero of the scale
Sunlight.
here and measure it like this. Yes. Then 4.
Object distance.
Object distance.
Should it be positive or negative?
Negative. Negative.
Negative.
Negative. Yeah. 5.
Image
Focal length.
Focal length.
Focal length.
is positive.
Positive. Is it clear how you decide the sign that you need to use when you are doing the problems?
Yes, ma'am.
Now we will go on to this. Just discuss quickly about this. In a concave mirror, what about the object distance? Just give me the sign.
Only, madam. Object distance.
What is it? Is it negative or positive?
Negative.
Negative.
Negative. Convex
Negative.
mirror.
Always negative,
Convex
ma'am.
mirror.
All the cases object
Negative.
distance negative.
All the mirrors are
Okay, very good.
It is negative.
Object height.
Object height is positive always, ma'am.
Positive. Positive for all the
Object height is also positive for all positions. Okay.
positive.
Focal length.
Yes.
Focal length,
Focal length inches.
For a concave mirror, where is the focal length? Focus.
5 plus.
It is in front of the mirror on the left hand side. So what
Negative.
should the focal length
Negative.
be? Negative.
Negative. Negative.
Okay.
Negative. Focal.
Yeah. What about convex mirror?
convex
Where
mirror.
is? Yeah. Where is the focus?
Positive focal.
Positive. Positive.
Positive focus.
Very good. One moment. What about radius of curvature?
Concave,
For concave, positive.
Concave,
Hmm.
negative.
negative, madam.
Yes.
Convex,
Yes.
Negative.
Okay. Let us discuss the image distance for these. Okay. Image distance in this case, is it positive or negative?
Negative, ma'am.
Negative. What about this case?
Second diagram also negative.
Negative.
Second diagram, image distance. Where is the image?
The image is sorry,
Here,
behind-
on the
behind-
right
behind.
hand side. So
Yes.
the image distance should be taken as
Positive.
positive. So both positive and negative are possible in concave mirror. What about convex mirror?
Convex mirror positive, ma'am.
What? Now, image height in case of the first diagram.
Negative.
Negative. The image height in the case of the second diagram,
Positive.
positive. What about this one?
Positive.
Convex mirror, always positive.
Positive.
Right? Now we'll go on to the mirror formula. I think you should make them understand what pole is, what focal length is, image distance is, object distance is by drawing all the ray diagrams. I think as before you start that, you can just brief them about all this. Distance between the pole of the mirror and the image is defined as the image distance. Distance between the pole and the principal focus is described as the focal length. So now we have two types of images, real images, virtual image. So now quickly we'll go through the sign conventions for them. Object distance, real and virtual image. What should be the sign for you for both real and virtual image? Object distance, you.
Negative, ma'am.
Negative for all
real,
cases.
real images.
Yeah. Image distance for real image.
Image
In
distance.
case of negative. Virtual image.
What position is a positive, ma'am. Virtual image positive.
Yeah, positive. What about convex?
Both cases. madam.
Positive, ma'am. Always
Positive.
positive.
Convex mirror, it should be positive or negative?
Image
Where is the
positive.
image form? Where is the image form?
Image positive, ma'am. Positive.
Positive. It is on the
Positive.
right hand side. Anything
Right
on
hand
the
side.
left hand side is taken to be negative.
Negative.
What about focal length?
Focal length is positive.
Negative for
Real image
concave.
is positive.
For convex, it is positive.
Positive for, yeah, good. Then object height, real image.
Positive, ma'am.
Positive.
Real image, object
Real-
height.
Real
Oh,
image.
object height is positive.
Real
Yeah,
image
you're
is
right.
negative.
For all, it is positive.
Yes,
Image
ma'am.
height
Image.
for real
Negative for
image.
real
Where is
image,
the
it
real
is
image
negative.
formed? Yeah, it is formed below
Perpendicular
the
below.
principal axis. So it is
Negative.
going to be taken as negative. Virtual
Negative.
image,
Virtual image is positive.
Positive.
Positive. ma'am.
positive. Convex mirror,
Positive.
convex mirror, positive, because always a virtual image. So mirror formula, it gives the relationship between focal length, object distance, and image distance. So 1 by f is equal to 1 by u plus 1 by v. This formula is applicable for both spherical mirrors and for all types of images. Sign conventions or mirrors should be applied to U, V, F, and R while solving numericals using the mirror formula. So we have a problem here. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Find the position and nature of the image. So U here is taken to be minus 10. F is plus 15. Why plus 15? Because it is a convex mirror. Yeah, it is on the right side. The focus is on the right side. So focal length will be in positive. So substitute the value. 1 by V will be equal to 1 by 15 plus 1 by 10. If you take the LCM, you finally get V. 1 by V will be 1 by the 5 by 30, or V will be 6 centimeter. Okay. Now they are asking you to find the position and nature of the image. So magnification is equal to minus V by U. So substitute the value of minus V, which is minus 6 by minus 10, which will give you 0.6. Now if magnification is less than 1, what is it? The positive sign implies it is a virtual erect image. The positive sign in front of magnification tells you that it is a virtual erect image, and any value below 1, less than 1, is always a diminished image. Okay, it's always a diminished image, and it is formed behind the mirror. Convex mirror image is always formed behind the mirror. Now if magnification is plus 1, what do you infer about the mirror?
The magnification is less than
Plus
the
1, plus 1. If magnification is plus 1, what do you infer?
Plus one means greater than the object. The image is greater than the object. Magnified.
Object size and image size are same, ma'am.
Plus 1. Plus sign indicates what? Virtual array.
Virtual image.
1 indicates
One
image height is
object
equal to
size.
object height.
Same size,
Yeah.
ma'am.
Same size.
Same size.
Which mirror will give that kind of an image?
concave mirror at C position.
It will be minus 1 then. I am talking about virtual, erect, and same size as the object. What is the mirror which is going to give you that such a kind of image?
Plane mirror. Plane mirror. ma'am.
Plane mirror, yes.
Yes.
Plane mirror always gives a virtual, erect, and same sized
size.
object.
Same size.
Okay, so magnification is minus 1. What do you infer?
Real and inverted image.
Real and inverted. Minus sign signifies real. So always
inverted.
treat the sign separately and the value separately. Don't think, read it together. That's what I'm saying. If it is minus 1, what does the minus sign imply?
Real and
Real
inverted.
inverted? Real inverted image. And 1 is going to be image size and object size are the same.
Same.
Which mirror is going to give such a thing? Which mirror will give magnification as minus 1?
Concave mirror.
Concave mirror.
Concave mirror. For which position?
At the
For all the 5.
center of curvature, ma'am.
Very good. At center of curvature. So if you see at center of curvature, so you can ask them to correlate the position of the ray diagram, the position of the image to the ray diagrams that we have learned now. So can you see here? Image height is equal to object height, and it is minus 1 because it is formed below the principal axis, which is real inverted image. Clear?
Yes.
So always correlate the problem. And so what do you think will be the position of the object here? For which position this problem is? This problem has been solved for which position? Where is the object? Any position in front of the mirror? Convex mirror? Okay. Now we'll go on to the next problem. An object is placed at a distance of 20 centimeter from a convex mirror of radius of curvature 40 centimeter. Find the position of the image and its nature. Okay. So u here is equal to minus 20. U is always negative. Focal length is positive because it is a convex mirror again. So 1 by f is equal to 1 by v plus 1 by u. So 1 by 20 is equal to 1 by v minus 1 by 20. When you take that onto the other side, 1 by v equals 1 by 20 plus 1 by 20, 2 by 20. So v is equal to 10 centimeter. Here again, you find the magnification minus v by u. So minus 10 by minus 20 gives you 0.5. So the plus sign in front of 0.5 tells you it is virtual array. 0.5 tells you it is diminished and it is formed behind the mirrors. This problem is also exactly like this. Only difference is they have given you the radius of curvature. So you should need to find the focal length by dividing it by 2 because radius of curvature is twice the focal length. Focal length is nothing but radius of curvature by 2. Hope you are able to follow.
Yes, ma'am.
Yes.
Can we proceed? Any doubts here?
Yes, ma'am.
No,
No,
ma'am.
ma'am.
Okay. An object is placed at a distance of 7 centimeter from a concave mirror of focal length 10 centimeter. Find the position and nature of the image. U here is minus 7 centimeter. Focal length is minus 10. Why minus 10?
It is left side.
Where is the
Concave mirror.
Left
Concave
side.
mirror.
It is on the left side. Very good. Focus is on the left side. So focal length measured against the direction of light is taken as negative. So 1 by f is equal to 1 by v plus 1 by u. Substitute the values and rearrange it. You will get 1 by v to be 3 by 70 or v will be 70 by 3. So 23.33 centimeter. Again, you are asked to find the position and nature of the image. Magnification is minus v by u. So it will be minus 70 by 3 by 7. Then you get the magnification as plus 3.33. Can you tell me what is the nature of the image here?
Virtual and direct, as it is left.
Virtual erect
enlarged.
because there is a positive sign.
Sign.
It is enlarged because it is greater
Greater
than 1.
Greater than 1.
So anything that is less than 1 is taken as
Diminished.
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 Anything more than 1 is taken as
Enlarged
enlarged. Clear? So treat the sign, negative sign, real inverted, positive sign, virtual.
Erect.
Okay. An object is placed at a distance of 20 centimeter in front of a concave mirror of focal length 15 centimeter. Find the position and nature of the image. U here is minus 20 centimeter. Focal length is minus 15 centimeter. So 1 by v, f is equal to 1 by v plus 1 by u. Substitute, you get v to be minus 60. Again, when you are asked to comment about the nature of the image, you always find the magnification. M is equal to minus v by u, which is minus of minus 60 by minus 20, which is 3 centimeter. So what do you infer from the magnification? Minus 3.
Real and inverted.
Real inverted. Minus sign tells you it is real inverted. 3 is greater than 1, which tells you it is enlarged. Am I clear?
Yes, ma'am.
Can you try this? Can you do this? An object is placed at a distance of 15 centimeter from a spherical mirror to give an image on the screen at a distance of 25 centimeter from the mirror. Identify the type of mirror. Find the focal length of the mirror. Find the nature of the mirror. Can you do this? So what is the formula? 1 by f is equal to
1 by v
1 by v
plus 1 by
plus
1 by u.
1 by u. Let us substitute. Before that, what is u value?
Minus
is u?
15 centimeter.
U is equal to
Minus 15 centimeter.
minus
15. 1 5.
15 centimeter. Okay. What is u?
25 centimeter. 25 centimeter.
B is given to be minus 25. We are going to take it as minus 25 because it is a concave mirror. Okay, let us substitute. 1 by f. Focal length you have been asked to find.
Yes, ma'am. Yes, ma'am.
1 by f is equal to 1 by minus 25
Plus
minus
1
of
by
plus 1 by 15. So what is the LCM? What is the LCM of 25 and 15?
75, ma'am. 75.
75. So this is going to be minus 3 minus 15 will go in 75 5 times, right?
Yes, ma'am. 5 times.
Minus 8 by 75 or f is equal to minus
75 by 8.
75 by 8 centimeter, right?
Yes, ma'am.
Then you are asked to find the nature also. So m is equal to minus v by u. Let us substitute here. Minus of minus 25 by minus 15. So you get the answer to be minus 1 point. What is the answer?
25 by 50.
10, 15 will 6 times, right?
1.66 வருது.
So this is the magnification. So you can infer that it is minus sign tells you it is real inverted
Real inverted image.
magnified, right?
Yes, ma'am.
Inverted.
Magnified image.
So what is the position of the object? What is the focal length? Focal length we got it as 75 by 8 comes to around
Yes, ma'am. 9 point something.
okay, minus 9 point
3. 9.3, ma'am.
9.375.
yes,
Hmm.
9.375.
375, ma'am.
Between C and F, madam.
So it is between C and F. See, focal length is
C and
minus 9.375. So from this, you know, where is the object? Object is at 15. So what should
Yes,
be
ma'am.
the radius of curvature? Twice 9.375. So the object is positioned between C and F. The image is formed beyond C. The image is formed beyond C and the magnification is minus 1.6. Clear?
Yes,
Able to follow?
yes, ma'am.
Shall we do another sum? These are some extra problems. We do this.
First one between pole and surface.
You have to give
Okay.
the numerical value.
Oh.
So what is given here? U is given to be minus 50. The magnification produced is 1 by 2, right?
Yes, ma'am.
Magnification is 1 by 2. Where should the object be placed to get a magnification of minus 1 by 5? So what is constant in this problem? What will not
U.
change in this problem?
U will not change.
Huh?
No,
U
no.
will not change, ma'am.
Okay.
But
Magnification is changing. Image distance will accordingly change. So what is going to be constant for that mirror? What is constant for this mirror? Yes. Focal length.
Yes, ma'am.
Whatever be the U value, whatever be the V value, focal length for that particular mirror or length is going to be constant, isn't it? So let us find the focal length. I will just do this sum. Can you tell me what u is? U is equal to
Minus 50.
minus 50
centimeter.
centimeter.
What is the magnification in the first case? It is 1
1
by
by
2.
2, ma'am.
We'll equate this to minus v by u, right?
Yes.
So this is equal to minus v by minus 50. So what is v going to be equal to? V is equal to, how will you find v? Minus 50 by 2, which is equal to minus 25.
Hmm.
So let us substitute and find the value of f. 1 by f is equal to 1 by v plus 1 by u. Substitute here. 1 by f is equal to 1 by minus 25 minus of plus minus 1 by
Minus.
50. So LCM is 50. This becomes minus 2 minus 1 minus 3 by 50. Or focal length is,
50 by minus.
what is focal length? The reciprocal of this, minus 50 by 3, right?
Yes.
So focal length is going to be constant. You want to get a magnification of minus 1 by 5, right?
1 by 5, yes.
So again, let us equate. What is it equal to? Minus u, you don't know. We'll keep it as minus 1 by 5 equals minus v by u. So let us express v in terms of u. Okay. So v is equal to okay. So let us substitute 1 by minus 50 by 3 equals 1 by v minus 1 by 5 v. Can you solve this? So this will become minus 3 by 50 equals, what is the LCM? 5v, which is 5 minus 1, 4 by 5v, right? When you cross multiply, you get v to be, I'll do it here. So what do you get here? V is equal to 50 into 4 by 50 into 4 by minus 3 into 5. So what do you get the value to be? 10 times. So minus 40 by 3. Right? From this you get the value of, you can get the value of u. So this way, always find, whenever they give magnification like this, always find the value of f, then substitute and get the value of v and u. Clear? Any doubts? Are you able to see?
Yes, ma'am.
Did you understand this problem?
Yes, ma'am.
Can we go on to the next one then?
Yes, ma'am.
Yes, ma'am, we can.
Sorry. Yeah. Can you do the next one? At what distance from a concave mirror of focal length 10 centimeter should an object be placed so that its real image is formed 20 centimeter from the mirror? Its virtual image is formed 20 centimeter from the mirror. You are asked to find the U value, U object distance. Focal length is going to be constant. They have given the image distance in both the cases. It is a concave mirror. So real image, if you are getting, you should take V as minus 20. Virtual image means you should take V as plus 20. Can you do it? What is given? What is the focal length? F is equal to
10 centimeter.
It is concave. So minus 10.
Yes, ma'am. Minus 10.
V is the first case is real inverted. So minus 20 centimeter. Real inverted images are formed on the left hand side. So let us substitute 1 by F is equal to 1 by V plus 1 by U. So 1 by F is minus 10 equals 1 by V, which is minus 20 plus 1 by U. So 1 by U will be equal to 1 by minus 10 plus 1 by 20. Right? So LCM is 20. So you get here minus 2 plus 1, which is minus 1 by 20, or U is equal to, you are right, somebody told me it is minus 20.
Yes.
That is the correct answer.
Yes.
Understood?
Ma'am, can we?
Similar.
Yes, ma'am. Can we interpret this as R is equal to 2F in that way?
R is equal to?
2F, like that we can interpret, no, ma'am. U
Yeah.
minus 50.
See, focal length is 20 means V is at minus 20 means it is at C,
Value.
right?
Yes, ma'am.
It is at C, so you should also be minus 20 because it is a real inverted image. Yes.
Well,
now the next one is V is equal to plus 20, right? So it should be a virtual erect image. Let us substitute 1 by minus 10 equals 1 by minus 20, no, plus 20 minus, what is the V? We have to find this, right? 1 by plus 1 by U. Okay, so you get here 1 by minus 10 minus 1 by 20 equals 1 by U. So LCM is 20. So it is minus 2 minus 1. So this will give you minus 3 by 20, or U is equal to minus 20 by 3, which will be minus 6 point something.
6 point. Yes,
6.67.
6.67.
So can you interpret the position of the object here? Focal length is 10. So U is minus 6.67. So it is within the focal length between P and F. So the image that you get will be a virtual erect and enlarged image. It will be a virtual erect enlarged image. So when as you teach them, so when you teach the ray diagrams, you can, when you do problems also, you can correlate it with the ray diagrams and teach them so that they understand in a better way. Okay. The last. Next up. If a concave mirror has a focal length 10 centimeter, find two positions where image can be placed to give in each case an image twice the size of the object. So what should the magnification be taken as here?
Greater than 1.
Huh?
2. 2, ma'am.
2 is magnification. So you have to do, see, in a concave mirror, 2 enlarged images are possible. Virtual erect enlarged is possible. Real inverted enlarged is possible. If it is going to be placed between C and F, you get the magnification as -2. If it is placed between P and F, you get the magnification as +2. So for both the cases, you should find. Shall we do this sum?
Yes, ma'am.
Tell me what the focal length is. F is equal to
Minus 10 centimeter.
F is equal to minus
10 centimeter.
1 moment. F is equal to minus
10 centimeter.
10 centimeter, right?
Yes, ma'am.
So magnification is, we'll do for, it can be plus and -2. Plus or -2. So first we will do for +2, which is virtual
Correct.
direct.
Correct.
Okay. So 2 here will be equal to minus V by U, or V is equal to minus 2U. So let us substitute 1 by F is equal to 1 by V plus 1 by U. So 1 by minus 10 equals 1 by V, which is minus 2U plus 1 by U. What is LCM?
To you.
To you.
So it will be minus 1 plus 2, which is 1 by 2U, or U will be equal to 2U will be equal to minus 10, or U will be equal to minus 5 centimeter.
5 centimeters.
See, focal length is 10. So U is placed within the focal length. So you get a magnified virtual erect image. Yes.
Yes, ma'am.
Now, let us take magnification to be -2. So -2 means it should be a real
And inverted.
inverted.
Inverted image.
So let us solve this. -2 equals minus V by U. So V will be equal to minus 2U, right? Oh no, plus 2U. Minus and minus gets cancelled. So substitute here. 1 by F is equal to 1 by V plus 1 by U. So which is 1 by minus 10. Focal length will remain to be a constant for that particular mirror or lens, whatever be the value of U and D. So 1 by U is 1 by 2U plus 1 by U. What's the LCM?
To you.
2U. So it will be 1 plus 2, right?
Yes.
1 by minus 10. So this is going to be,
To
U
you.
will be equal to minus 30 by 2, right? Minus 15. Minus 15 centimeters. So what is the position? Can you tell me? Focal length is 10. Radius of curvature will be 20. So U should be between C and F to get a magnified real image. That way you can verify the answer. Clear?
Yes, ma'am.
Any doubts?
No, ma'am.
No, ma'am.
One last sum. Can you do this? So again, it is given that
V is equal to 30 centimeters.
mirror is in the center. We don't know what the mirror is. You get an, you are placing the object here. The image is formed. Let us assume it is formed here. This distance is 30, right?
Yes, ma'am.
Distance between the mirror and the object is 30. No, between the image and the object is 30. So let us take this as x. This will be 30 minus x, right? So let us substitute. Magnification here also, two types of magnification are possible, plus and minus. So if it is virtual erect, it will be magnification will be +2, which is equal to minus b by u. B will be minus 30 minus x by u, which is minus x, right? Yes or no? So this will be minus 2x equals minus 30 plus x. So x will be 3x will be equal to minus 3x is equal to minus 30, or x will be equal to minus 30 by 3 minus 10 centimeter. So what will v be in this case? V will be, what will v be? X is minus 10. 30 minus of minus 10 plus 40. Yes? Yes or no?
Ma'am, can I have a look on a question, ma'am, on the question, ma'am, please?
What do you want to see?
Question, ma'am, question.
Question,
Yes, ma'am.
So this is similar to that sum, except that
Thank you, ma'am.
likewise you can do for minus 2 also. Okay.
Yes, ma'am.
So you have to do for both the types of images. So you're getting two types of images means what should the mirror be? It should be only a concave mirror.
Concave mirror.
Concave because convex will always give a
Diminished.
virtual erect image.
Virtual erect.
Clear?
Yes, ma'am.
Yes, ma'am.
Any doubts?
No, ma'am.
Okay. So I thought we'll go next. What is the next topic? I thought I'll discuss refractive index. Shall we do that?
Yes, ma'am.
Shall we do refractive index? Because lens problem are also similar to the mirror problems, only the formula is different. Sign conventions are also going to be the same. So we'll go on to reflection, refractive index. Children find this a little bit difficult. So I thought I will go into this. So what is refractive index? It's nothing but the ratio of sin I to the sin R, which is a constant. So the constant that you get is going to be constant for a particular color and particular pair of medium. So it is a measure of the bending of the light upon refraction. It gives you an indication of how the optical density of the medium. Okay, so absolute refractive index is nothing but the speed of light in vacuum to the speed of light in a medium. It is comparison of velocities of light in two media. Will it have a unit?
No, ma'am.
No, because it is a comparison of two light terms. So here you have an incident ray it is going into, from vacuum, it is going into a medium. So it is going to bend towards the normal. Sin I will be greater than sin R here. Okay. So it is a ratio. Can you do this? Light enters from air to glass, where the speed of light in glass is given as 2 into 10 to the power 8 meter per second. Calculate the refractive index of glass.
1.5. 1.5, ma'am.
Yeah, 1.5. It is 3
Because it
into
is
10 to the
2,
power
3
8.
by 2 will,
Velocity of light in air. Absolute refractive index earlier, I just show you.
3 by 2 we will get, ma'am. So it will give.
Yeah. 1 minute. Absolute refractive index of two media is what? Wait a minute.
When one of the medium is air,
We went
C
off
by
to
V.
some other-
N is
We went
equal
off to some other page. Yeah. Comparing the absolute, no, this is relative refractive index before that. Yeah. Speed of light in vacuum by speed of light in the medium gives you absolute refractive index. So we will do this. What is the speed of light in air or glass or vacuum?
3 into 10 power 8.
3 into 10.
3 into 10 to the power 8, 3 into 10 to the power 8 meter per second. What is the speed of light in glass given as 2 into 10 to the power 8? So 3 into 10 to the power 8 divided by 2 into 10 to the power 8 gives you the refractive index of glass, absolute refractive index of glass, which is 1.5. 3 divided by 2 gives you 1.5. Relative and refractive index is comparing the refractive index indices of two media. You compare the absolute refractive index, say glass and water. Glass with respect to water. Always the absolute refractive index of glass will come on top. The absolute refractive index of water will come below that. So comparison of two absolute refractive indices gives you the relative refractive index of one medium with respect to the other. The refractive index of water is 1.33 and that of glass is, it's given. What is, I'm not able to see. What is the refractive index of glass?
1.5, ma'am.
Okay, 1 point. So you are asked to find refractive index of water with respect to glass. So water will come on top divided by the refractive index of glass in the first case. So 1.33 is the absolute refractive index of water and glass it is 1.6.
5, ma'am.
0.5.
1.5. So it will be 1.33 by 1.5, which will give you
5.
water with respect to glass. Am I
Glass.
clear? So what will it be for glass with respect to water?
1.5.
5 by 1.3. So when you're comparing the refractive indices, it will be in the same order. Water with respect to glass means water first followed by glass. Okay, if you are comparing the speed of light in two different medium, it will be the reverse. Okay, refractive index of medium 1 with respect to medium 2 will be velocity of light in medium 2 divided by velocity of light in medium 1. Clear? This doubt, children always find this very difficult. Can you do this? Velocity of light in water is 0.25 into 10 to the power 8 meter per second and that of glass is 2 into 10 to the power 8 meter per second. Calculate the refractive index of water with respect to glass and glass with respect to water. Can you do this? So water with respect to glass means you're comparing the velocities here. So velocity of light in glass divided by velocity of light in water. So it will be 2 into 10 to the power 8 divided by 2.25 into 10 to the power 8, which will give you 0.88. Okay.
Yes, ma'am.
Second case, it is glass with respect to water. So velocity of light in water divided by velocity of light in glass, which will be 2.25 into 10 to the power 8 by 2 into 10 to the power 8.
By
Clear? So this is how you do when you are comparing the velocity of light in two different medium. Any doubts? So let us have a recap. Sin I by sin R is n. Absolute refractive index is a comparison of speed of light in air or vacuum to the speed of light in the medium. Relative refractive index is nothing but the absolute refractive. See, if it is relative refractive index of medium 1 with respect to medium 2, it will be absolute refractive index of medium 1 by the absolute refractive index of medium 2. Then here, relative refractive index of medium 2 to medium 1 will be absolute refractive index of medium 2. So whatever comes first will be on top. Whatever comes next will be below. Clear?
yes,
Or
ma'am.
when you're comparing the velocities, it will be the reverse. Velocity of light in medium 2 divided by velocity of light in medium 1. Here again, velocity of light in medium 1 divided by velocity of light in medium 2. And refractive index is inversely proportional to the speed of light. That means what? If the refractive index is a measure of the optical density. If the refractive index is more, speed of light in that medium will be less. If the refractive index is less, the speed of light in that medium will be more. The refraction, why does the refraction of light happen? What is the cause for refraction of light?
Variation in the speed.
Variation in the speed when they move from one optical medium to the other. Clear?
Yes.
Then is refractive index and mass density same? Optical density and mass density same?
Mass density and optical density are different, ma'am.
Are they same?
No.
No.
No. Here we are comparing the speed of light. Okay. There we are comparing mass by volume, isn't it? So, if you take the example of kerosene. Kerosene is less dense than
Water.
water, isn't it? It is less dense than water, but it's optically more dense than water. Okay? So it will float on water. The mass density of kerosene is less than that of water.
Less than that of
So it
water.
will float on water, but its optical density is much more than that of
Water.
water. So how do you think? 1 minute. See, it also tells us about the optical density. Optical density is not. How do you classify optical density? You classify it as rarer medium and denser medium. So the refractive, which has the highest refractive index?
Air.
Which has the highest refractive index? Highest refractive index.
Air, no, ma'am.
Air has got the least.
Least.
1.003. Vacuum is 1.
One.
Which is very dense,
Diamond.
optically denser. Huh?
Diamond.
Diamond 2.42. If you check the values, you get it like that. They are asking you to find the absolute refractive index. In air, it will be 3 into 10 to the power 8 divided by 2.4 into 10 to the power 8. That will give you the refractive index of the liquid. Absolute refractive index of the liquid. Okay. So it will be 3 into 10 to the power 3 divided by 2.4. So what should the answer be? 3 divided by 2.4. What are you doing?
1.25.
Okay, that will be the refractive index. Can you do the next sum? A speed of light in air is 3 into 10 to the power 8 with the refractive index of 1.5. Find the time taken by light to travel a distance of 10 centimeter in the glass. Air is 3 into 10 to the power 8 with the refractive index 1.5. Find the time taken by light to travel a distance of 10 centimeter in the glass. How will you do this? So what is
Can you
given here?
speed is equal to velocity is equal to displacement.
Velocity of light in air, isn't it? Air
Yes,
is
ma'am.
given to be 3 into 10 to the power 8.
Yes, ma'am.
Meter per second.
Mm.
And the absolute refractive index of glass with respect to air is given to be 1.5, right? So we can find the velocity of light in glass. How? This is equal to velocity of light in air by velocity of light in glass. So what will be the velocity of light in glass? Will be equal to velocity of light in air by 1.5, which will give you 3 into 10 to the power 8 divided by 1.5, which is nothing but 2 into 10 to the power 8 meter per second, right? So you have found the velocity of light in glass. They are asking you to find the time taken for it to cover a distance of 10 centimeters. So distance is given to be
10
10
centimeters.
10
centimeter,
centimeter.
which is equal to 0.1 meter.
Yes, ma'am.
Yeah,
Yes.
convert it into SI unit. So what is time? Time is equal to distance by speed. Distance by speed. So what is the distance given here? 0.1 divided by
0.1 meter.
2 into 10 to the power 8. So what will be the time? I can write this as 10 to the power minus 1. This 10 goes up, it will become 10 to the power minus 8 by 2. Right? So it will be 0.5 into 10 to the power minus 9 seconds. Clear? Any doubts here? Are you able to follow?
Yes, ma'am.
Ma'am. Yes,
Can
ma'am.
we go to the next problem then?
Yes, ma'am.
Yeah. One moment. Refractive index of glass with respect to water is 1.125 The speed of light in water is 2.25 into 10 to the power 8 meter per second. Calculate the speed of light in glass. This is similar to what we did just now. Can you do it? Sorry. How will you do this? Refractive index of glass with respect to water. And the speed of light in water is given. So glass with respect to water means speed of light in water divided by the speed of light in glass is equal to 1.125. Correct? Yes or no?
Ma'am. Yes, ma'am.
So what did you get the answer to be? From this, can you find the speed of light in glass?
Yes, ma'am. 2 into 10 to the power 8.
You are getting 2 into 10 to the power 8 meter per second. All of you?
Yes, ma'am.
You want me to work out or you know to do this?
We did not.
You are able to do. Okay. So the absolute refractive index of sapphire and diamond are 1.77 and 2.42 respectively. Find the refractive index of diamond with respect to sapphire. How will you do this? Diamond with respect to sapphire. So what will come on top? What will be below that? You are comparing absolute refractive index of two different medium. So when you are comparing the absolute refractive index of two different medium, it will be in the same order. What is it for diamond? It is 2.42 divided by 1.77. Understood? So when you're comparing velocities, it will be the reverse. But when you're comparing the refractive index, it should be in the same order. Clear? So it will be 2.42 divided by 1.77. What is the answer? What is the answer?
1.36.
1 point.
Okay. So I was able to cover numericals in mirror problems and refractive index. We'll do some numericals in lens. It is going to be the same. The sign conventions of what we learned for mirror holds good for lens. The only difference is the difference in the formula. 1 by f is equal to 1 by v minus 1 by u. Magnification is equal to v by u. Okay. So all other concepts are going to be the same. So tomorrow we will do little bit of problems in electricity. Electricity has got a lot of problems.